out of this would be magnesium sulfate, which, by the way, is clear and colorless. Right? So magnesium 2+ in an aqueous solution doesn't have a color associated with it, right? It's just clear in color. It would look like a glass of water. And then what you would get as a precipitate would be just the solid copper. This is the very last step of the reaction where you get your copper chunk back again. Although after you've terrorized it for 5 reactions, it's not coming back as a shiny chunk. It'll probably look like soggy raisin bran without the raisins, but you get your copper back again. In this step, you would have noticed that you had gas evolving. Do you see gas anywhere in that reaction equation? I don't. But here's the deal. In the previous step, you added to your copper oxide. So this was a solid. You added some dilute sulfuric acid. And you don't know if you added too much because you're just following the procedure, right? And you're adding your sulfuric acid, and what you're supposed to get is the copper 2 sulfate that you're going to react in that that next step with the magnesium. And some water that no one notices because it's just in solution. But here's the deal, you guys. You might have some leftover sulfuric acid. Potentially. And not everybody's going to have the same amount, right? When you decanted your copper oxide, your copper 2 oxide, the solid, some people may have accidentally poured a little copper down the drain, so you don't need as much of the sulfuric acid, right, for this step. So some of you would have had more leftover sulfuric acid than others. Some of you very little bit. Everybody would have had a little bit left over because we told you guys in that step to add a little bit of an excess. We didn't say that to you. We just said, hey, add 10 mils of this stuff, right? And you don't know if it's excess or not. You're just following the procedure. But it was an excess. And what ends up happening is that excess is going to react with the magnesium solid. Now, the magnesium is also busy reacting with the copper 2 sulfate, right, to make magnesium sulfate. But that little bit of leftover proton in solution is going to give you the magnesium sulfate, which is great because that's what you were making anyway. But it's also going to give you some hydrogen gas. So this right here would have been the gas. It's a byproduct, right? It's not what you were aiming for, but you had leftover acid in the flask. And so it reacted with the metal to give you hydrogen gas. Okay. So that's one example of a gas evolving reaction that kind of didn't happen on purpose, but you never know. Sometimes byproducts happen. That's okay. Next reaction. This is more like if you were to take a Tums calcium carbonate. In this example, we're using sodium carbonate. Doesn't matter. Essentially, it's the carbonate anion in solution, and that's going to react with some dilute hydrochloric acid. Let me draw out this reaction equation. So we've got sodium carbonate, and this will be in solution. So you can take, and this will be a clear, colorless solution, you guys. It looks like a glass of water. So you don't even know what's in there, right? We're going to label that for you sodium carbonate. And then to this, you're going to add some dilute hydrochloric acid, meaning we have an aqueous solution of hydrogen chloride. And what are we going to get? We're going to get 2 equivalents of sodium chloride, and that will be in solution. And what else are we going to get? Carbonic acid, also in solution. This stuff, this carbonic acid, is going to react with itself to produce carbon dioxide, which is a gas, and water. And that's going to be a liquid that you don't see because it's all aqueous, right? what just happened? Let me draw it a different color down here. So I'm going to take the spectator ions out. The chloride and the sodium are just spectating. So I'm going to just take the net ionic equation here. So what's happening? Well, I've got the carbonate anion, right? So this is what this looks like. And I'm going to just draw one of the resonance forms. It's no need to draw all of them. So the hydrochloric acid, so hydrogen chloride in an aqueous solution is just a source of a proton, right? So we're going to protonate this thing. We're going to do one at a time. You don't have to regurgitate this reaction, by the way. I'm just showing you how this thing happens. And by the way, it's taking me so much more time than the reaction actually takes just to write it out, right? So here we have our carbonic acid. This happens in like an instant, it seems, right? When you are doing this reaction, when you take the Tums, right, and the carbonate anion is protonated by the excess acid in your stomach, this thing can attack itself. So I'll just go from this side to this side. That oxygen is going to grab that hydrogen. Those electrons are going to go on the oxygen. What do I get? I get this. So now, if these electrons on this oxygen that was just deprotonated collapse to form a double bond between that oxygen and that carbon, we can kick water off. And that's what you get. And the carbon dioxide gas would be one of your products. This is also a gas evolving reaction. So if you do a reaction that just happens to produce a product that is in the gas phase, it is considered to be a gas evolving reaction. You guys only have to worry about the reactions in this table. I'm not going to give you anything weird or, fancy that you don't see here. I'm just going to be honest with you right now, I'm probably going to pick a carbonate or a bicarbonate. But just keep an eye out, like on the quiz, for example, you might see some of the other ones. But these are the gas evolving reactions that your book chooses to cover. And so those are the ones that I'm going to be sort of committed to. But these are two specific examples that you may have come into contact with, while you were doing chemistry in the lab or when you were doing antacid chemistry in your stomach or whatever. But that big burp that you get after taking a Tums, that's the carbon dioxide, right, from that gas evolving reaction. The hydrogen gas that looked like an Alka-Seltzer in your copper lab, a lot of people think that has to do with the copper reacting with, the copper 2 sulfate reacting with the magnesium. Because they don't realize you can't see sulfuric acid, in solution like that. It's like you don't know that it's there. And you add metal to an acid and boom, you get, hydrogen gas, and you'd know it right away. All right. So I'm going to stop recording this here. This is the part that I think people were saying got a little messed up last time. I think I've gone a little bit over. I'm at 14 minutes now. And I think they said this first 7 minutes was a little messed up. So I'm only doing the gas evolving reaction part. You let me know if you can hear this okay. And I'll leave the rest of the other video up as it is. It seems like that the rest of it came out okay. It was just that the beginning 7.5 minutes that was a little fruity. And just so we all know, if this does work, I will break the lectures into smaller chunks. I think it's probably easier for the editing software, whatever is happening to these videos after I produce them or whatever, to be in smaller chunks. So we'll see how it goes. Thank you for your patience, by the way.